Sleep deprivation is literally brain damage.
What Bryan Johnson doesn't know about the brain and sleep is a lot. The study that Johnson is referring to was a 10-year-old study that looked at acute sleep deprivation increases serum levels of neuron-specific enolase, NSE, and S100 calcium binding protein B, S100B, in healthy young men.
A study in young participants showed that one night of bad sleep increased levels of this protein called S100B by 20%.
He failed to really describe is this wasn't one night of bad sleep. It was one night of total sleep deprivation. And then spaced apart by 4 weeks with young men that were able to sleep the full day. And they used 3 biomarkers: NSE serum, S100B serum, and the A beta 142 to A beta 140 ratio. All of these in the plasma. And this was after total sleep deprivation. And
literally brain damage. A study in young participants showed that one night of bad sleep increased levels of this protein called S100B by 20%, the same level as caused by a traumatic brain injury.
They found was that this 20% difference, approximately, in these healthy young men were seen mostly in the NSE serum levels, neuron-specific enolase. And this is the kind of the graphic to unravel. The black is the serum enolase the night before, and then the black over here is the night. After they slept the night, they have their morning measurement. The white would be the level the night before, and then the total sleep deprivation here in white comes up and shows you that that is the large increase in the NSE levels. So again, the black was the evening before they went to bed, black is sleep, and those levels are lower the next morning. The white is total sleep deprivation. They kept the lights on. They didn't let the people sleep. And there was an increase of around 20% in the NSE and S100B protein, measurements. And really, the point is that while these biomarkers, let's say the S100B, is a widely studied biomarker for traumatic brain injury, it's not necessarily extra specific because it varies on the labs and things like that. And the S100B was not really that great of a difference. Really, the statistics should be before and after, not really the change of these people. But S100B is a small dimeric calcium binding protein.
Now what happens is it enters the bloodstream, it leads to toxicity, which can lead to neuronal death.
Protein that belongs to the S100 protein family. And unlike NSE, which is found primarily in neurons, S100B is most abundant in the astrocytes, a type of glial cell that supports neurons in the brain's spinal cord. It serves as a sensitive indicator of glial damage, making it particularly useful in the assessment of brain injury. In this study, they demonstrated that healthy young men, that a single night of sleep loss, total sleep loss, the morning serum concentrations of NSE and S100B were about 20% higher relative to the values obtained after one night of sleep. And that therefore, these factors are usually found in the cytoplasm of neurons in glial cells. And these findings therefore suggest that a good night's sleep may possess neuroprotective function in humans. And the reason why is that during normal sleep-wake cycles, sleep represents a period during which brain glucose metabolism drops by about 30% compared to the values obtained during wakefulness. In contrast, during nocturnal wakefulness, this activity of being awake creates more nerve activity, ultimately leading to the production of reaction oxygen species. And this higher activity in the night shows that this increased ROS can damage neurons and even induce cell deaths. With this in mind, the morning serum concentrations of NSE and S100B observed after a single night of sleep loss might be caused by an increased nocturnal ROS production in the brain, not the body. Here we can see the biomarker changes and sleep deprivation. So you can look at the S100B, the NSE, and really the most important one is the glial fibrillary acidic protein, or GFAP. And these markers usually go up with acute sleep deprivation, chronic poor sleep, and cognitive function goes down. And these are also significantly connected to sleep quality. So higher S100B and NSE levels are correlated with worse sleep quality and shorter sleep duration. And GSHAP also shows a positive correlation with poor sleep studies. And these elevated biomarkers are associated with cognitive dysfunction, including poor general cognitive function and working memory deficits. And partial and total sleep deprivation are known to impair sustained attention and alertness during the day, which can be objectively measured using the psychomotor vigilance test. And the effects of total sleep deprivation on the PVTB shows that significant declines in PVTB performance, including slower response speeds, increased lapses, missed responses, and more false starts. And partial sleep deprivation, such as several nights of restricted sleep, also impair PVT performance. And that's why we created the BrainSherpa. The BrainSherpa is like a Fitbit for your brain. It gives you your morning readiness scale. It's available in the Google Play Store. And these are the outputs that we get of your reaction time, your cognitive speed, your cognitive variability, your cognitive performance, as well as resiliency, focus, and flexibility throughout the day.
So how do we stop this from happening? Get high quality sleep. You are a professional sleeper. Bedtime is the most important appointment of the day. Be on time and respect yourself.